Hello, and welcome back to our ongoing series Rusteroids, recreating an Asteroids clone using Rust. Today, we will be adding collision detection to the asteroid, so that when it collides with the player, it will reset the world back to its original state, effectively killing the player character. As usual, let's check that we have the code running from the previous tutorial. If you don't have this code, you can simply run git checkout tutorial 8 to get the previous code. The ship and asteroid move around each other, but at the moment the asteroid simply passes through the player. We are about to change that. The first thing we want to do is add a new implementation of a run method for the asteroid. This will be added to the bottom of asteroid.rs under our previous one of asteroid mover. This new implementation will be called Asteroid Collider, and we first create the empty struct. Immediately after that, we will add in the implementation of the Asteroid Collider, again creating a lifetime of A. As we did last time, we will add in a type for system data, and we will be taking the right storage for position. Then, to save time, we'll simply copy and paste the remaining items, where we'll get the renderables, players, and asteroids. This time, however, we're also going to add in a reference to the entities object. This will allow us to change the global objects on an entity level, and not just a component level. Don't forget the semicolon to finalize the line. And, as before, we now create our run function with arguments of self, which is mutable, and system data, also mutable and simply named data. The next bit should seem familiar as we gather references to the position, renderables, player, and asteroids as part of a tuple, adding in a reference to entities as well, each extracted from the data object. Now we'll loop through all of the players, gathering the player positions, player renderables, and entities, ignoring the third item. Calling .join at the end to get each of those items as an iterable. Inside this loop, we're going to loop through each asteroid. We do that by grabbing the asteroid position, asteroid renderable, and ignore the reference to the asteroid object itself. These are the objects contained within the positions, renderables, and asteroids objects respectively, again joining them at the end. First, we get the difference in the x positions for both the asteroid and the player. We take the absolute value because we don't care about the sign on the value of that calculation. We do the same thing for the difference in the y positions. Next, we calculate the hypotenuse between these objects, which will give us the actual distance between them. Using Pythagoras' theorem, we know that we just need to multiply the diff x variable by itself and add it to the diff y variable, after it has also been multiplied by itself, and then we will take the square root of that result. And I forgot to put the equals sign in, so I'll do that now. Now, we can just check if our hypotenuse is less than the asteroid output width plus the player output width as an F64 and then divide it by 2 because the center point is in the middle. This will tell us if the two images are overlapping, although only in a circle around the center point. If this happens, we will add in a print line to let us know on the console that this has been triggered. This is just for debugging purposes. Then we call entities.delete to delete the entity. This doesn't remove the entity yet, but simply marks it for deletion on the next maintenance cycle. We will add in a call to the maintenance cycle in a moment. Returning to main.rs, we need to register our new dispatcher object to the list. We can simply put it after the previous one, which was Asteroid Mover. As before, we call with and pass in the Asteroid Collider object, calling it the same as the class name but in snake case, and passing in an empty list. And now we scroll down to our dispatcher.dispatch method, and we add in a call to gs.ecs.maintain to clean up any items that have been deleted. Trying cargo run, we can see that we've missed a couple of things. Going back to the asteroid.rs file, we need to add in a reference to entities inside the specs prelude package. With that added in, we now try cargo run again, and we can see the asteroid is moving. If we crash into it, we see the player disappearing as expected. Next up, we're going to go to our game.rs file and scroll to the update function at the top. Before we do anything else, we will check the status of the game world. We first create a Boolean variable and call it mustReloadWorld, and we will set the initial state to false. Then we create a scoped area inside the function. This is to tell the compiler we want to release any borrowed references before we try and use them in the code underneath. We then grab a read-only reference to the player list in the same way we normally would. Once we have this reference, we can call the count function on the players list. After joining it first, we check to see if the number of players is less than 1, which implies all the players are dead. And if this is the case, we set our boolean of mustLoadWorld to true. Outside and underneath of our scoped area, we can now check if mustReloadWorld is true, and then we can call our ECS and delete all of the existing entities. This is the section where we would have had a problem had we not scoped the use of ECS above. The borrowed value would not have been returned yet, but by scoping it, we tell the compiler to return the variable for us to be able to delete all of the existing entities. And we can call our loadWorld function, passing in the ECS. You'll remember that the loadWorld function adds our initial entities, the player and asteroid. Calling this in this way will effectively reset the world back to the starting positions. Running cargo run, we can see that we accidentally put an extra S on the end of the player component. We remove that. And we recompile the code by running it. Then we will deliberately crash into the asteroid and verify that it resets everything back to its initial state. This is adding in real danger for the player character, and we're on the way to making this a challenging game. Join us in the next session, where we'll be adding in a missile firing code to give the player a chance to fight back against the asteroid. If you enjoyed this video, please subscribe to our channel and hear about the next video when it comes out. For now though, I'll wish you a good day and hope to see you again soon. Bye for now.